Hello everyone, my name is Alkım Akarsu and I'm an electric and electronics engineering student from Bilkent University. In this video I'm going to present you my EEE 102 term project. So basically I made a robot that mimics the movement pattern of a primitive robot vacuum. Let's first start by physically examining it. This is the robot I made. This is a DC motor controller which controls the two DC motors under the robot. There are 1, 2, 3 and 4 infrared sensors. 2 of them are facing downwards to detect cliffs and 2 of them are facing forwards to detect objects that this ultrasound sensor could not detect. We have 2 9-volt batteries connected in parallel here. These are only responsible for powering these two motors. All of the other electronics are powered by these 4 1.5 volt batteries. We also have a servo motor here, which on top of it has an ultrasound sensor. This sensor detects objects and how far away they are, so we can make decisions as to how to move the robot with it. The servo rotates the sensor and it scans the area for objects. We also have a breadboard mainly for distributing power, and then we have the Basis 3 FPGA board which controls the robot. So the main logic of the robot is as follows. The default state is going forwards. It always goes forward and it waits to encounter a detection. A detection can be a cliff or an object in front of it. In either case, according to the direction of the detection, the robot reverses and then turns to the other direction, then goes forward. So that's the basic principle of it. Now let's see the robot in action. So I powered the robot on, turned the robot on by using this switch. Here, the first two switches control the speed of the robot, and the second two switches, the two switches after that, control the detection distance. The rightmost switch enables or disables the motion. So if I have the speed on 0 and turn the robot on, you can see the servo motor turning and the ultrasound sensor scanning the area. If I show my hand to it, it will stop because it sees an obstacle here. And it will do the reverse and turn maneuver. So first we will see how the robot reacts to cliffs. Because there are no objects that reflect the sound waves from the ultrasound sensor, it won't detect anything. So let's see how it reacts to cliffs. As you can see, the robot turns when it encounters a cliff. Now, if we get an object that is reflective to sound waves, such as a mirror, we can test the ultrasound sensor of the robot. First, we turn the robot on. Then we put this, and it detects it and goes backwards, as you can see. We can increase the detection distance if we want for easier detection. Like this. Thanks for watching.